Welcome back. Today we're going to be sketching polar equations. I would like for you please to take out your classic polar curves cardstock purple paper that has a basic form of each type of polar curve that we'll be looking at. We are going to primarily be focusing on the circles, the limacons, and the roses. You can tell which type of polar curve you're graphing just by the form of the equation that's given. So a regular basic circle will have r equal to some number, cosine theta or sine theta, depending on if the number is positive for cosine or negative for cosine. That will determine whether the circle is to the left or to the right of the origin. As for sine, a positive would be above and a negative would be below the origin. Hopefully that makes a little sense too, in terms of cosine being associated with the x-coordinate and sine being associated with the y-coordinate. The limacons are going to have a few different shapes with those as well, and that all depends on, again, what you're given. We have an A and a plus or minus B position, both with sine and cosine, and the size of A and B will actually determine what sort of shape we get, not whether it's sine or cosine, but the position of the A and the B. Then there's also the roses, and that will give you a value in front of theta, or in front of your angle, that's going to be different, and that value again will determine how many petals you get in terms of the sine and the cosine. So let's go ahead and take a look at our first curve. This one is in the form of r equals 3 plus the cosine theta. So if I look back at the classic polar curves, that looks most like a limacon, which gives us an A plus or minus B, and we're looking at an 3 plus or minus 3 cosine theta. Well, if I put my A and my B in this equation, my A is 3 and my B is 3. If I set it up as A over B, I would have 3 over 3, or 1. If I look back again at my classic polar curves, then I know that I am going to be graphing, in this case, a cardiac. So I will classify that as a cardiac. Now, in order to graph, I need to be able to actually graph the cosine function as we've done in the past. So I'm going to be looking at this graph as y equals 3 plus 3 cosine theta. If we go back to chapter 2 when we first learned how to graph sine and cosine, I remember what the cosine graph looks like. I also know that the 3 plus in front will give me a vertical shift, and then the 3 that hangs out in front of the cosine part changes the amplitude of the graph. So if I sketch this graph, 3 plus 3 cosine theta, I am going to move the entire graph up 1, 2, 3. Remember, I always said it's a good idea to take a new color. So the center of that graph is going to rise up 3 units. And then the amplitude of that graph will go 3 above and 3 below. So I have a graph that will top out and bottom out. Again, 3 above and 3 below that center at 3. And then I can just graph a regular cosine graph. Remember, we do 4 tick marks. Hopefully this is ringing a bell to you. I will have pi over 2, pi, 3 3 pi over 2 and 2 pi. Keep in mind that because there is nothing in front of theta here, theta stands alone, we're just going to base it off of the regular unit circle, so 2 pi. And so when I graph my cosine graph, cosine starts up, then it goes to the middle position, bottoms out, back to the 0 position, or the middle position, and then tops up to here's my cosine graph. Now, how is this going to help me plot my point? Well, because each of these points on this cosine graph are going to give us a polar coordinate that we can plot, and then we'll connect those as curves. So if I think about this very first point here, this position right here at that point, that's when the angle is 0. Angle is 0 again, and the y-coordinate here is 6. Well, how is that going to translate into our polar coordinates? Well, I'm going to call this axis the x-axis, the typical x-axis. That's going to give me all of my thetas, and the y-axis is going to give me all of my r's. And so even though I put this point in as 0, 6, I'm actually going to end up flip-flopping them and write it in the correct form of a polar coordinate, which is r comma theta. So my r is 6, and my theta is 0 pi. Now I can go through, and every point that I point out here, I can create another polar coordinate. So if I move over to the pi over 2 position, my theta is pi over 2. Well, my radius comes from how high up I go, and I will put that at up 1, 2, 3. That's the new center of the graph, so that's the point 3 pi over 2. I can continue to go through my graph that I made and pick up several other points that I'll be able to plot. So if I think about the position at pi, it rose 0. And I'll move over to the next one where I'm at 3 pi over 2 with a radius of 3. And then lastly, I'll end at 2 pi with a radius of, back up to where I started, 6. So again, I'm just sort of following through this graph with my typical x, y flipped and put in terms of r and theta. So I'm just sort of finding what that coordinate is. Now, these are my polar coordinates that I've collected here. All of these are going to get transferred to my graph, and then I'll connect them in a curve. So I'll start with my first one, 6, 0 pi. That means that I'm going to move out 6 and not open up an angle at all, because 0 pi would be right on that axis to the right of the origin. So there's my first point. Then I'll do 3 pi over 2. So 3, I'll move out to 3, follow that up to pi over 2. There's my next point. Then I have 0 pi. Well, that's 0 in the pi position. This one's a little bit weird because in the pi position, I'm not actually moving out. I'm at the origin 0, so it's going to be stuck in that center area. Keep going down, 3 pi over 2. So at 3 pi over 2, 1, 2, 3, I'll be in that position. And then it goes back to where I started from. 6, 2 pi is the same as 6, 0 pi. So you should have learned how to graph these points yesterday on your notes, and so now we're just sort of putting them together. Now, when I look at this, if you kind of look at the way the graph itself or those points look, it feels like it just doesn't tell you a whole lot. But keep in mind that these are curves. These are polar curves. And so if you think about how this graph of cosine is a curve all the way throughout the graph, when we plot our points or connect our points, they're also going to be curves. So when I do my first position, here's my curve, and I'm just going to curve into the center and curve around and curve to the finish. And then I've got my cardioid, or sort of heart-looking polar curve. So it's a matter of plotting the graph, pulling out the points, and then connecting those points in a curved fashion. So let's move on to our next one. This one is 2 plus sine theta. Again, I can go back. If I think of this is an a plus b, the last one, it's the same, a similar fashion. If I put a over b, I'll put 2 over 4, which is 1/2. Go back to my choices, and that, again, fits in the Limousin category. As I go down, is my a over b less than 1? Yes, it is. So what I'm going to have is a graph that's going to have a sort of inner loop in it. And so I want to keep that in mind when I'm graphing it. This picture here is going to be what graph number 2 sort of looks like. Now again, if it's sine or cosine will determine the direction of the loop that it goes, and so I'll keep that in mind as well as I graph, but it needs to be a loop. So I will start with a graph of that function, 2 plus 4 sine theta. So I'll make my x and y coordinate, or x and y plane that I always start on. This is, I'm going to be graphing y equals 2 plus 4 sine theta. Again, I am not changing the angle at all, so I'll base that off of 2 pi. But I am going to move this graph's center up 2 units. So I will go up 1, 2, there's my new center of my graph, and then keep in mind the sign will top out 4 above that and 4 below that. So it's the sort of max of the graph, and down here is sort of where the graph itself is going to bottom out. And when I graph a sign, it starts at the 0, then goes up to the highest point, back down to 0, down to the lowest, back to the 0 position. So my 0 is moved up 2 units, so there's my new sine graph. Again, I'm going to be looking at my x-axis to give me theta, and my y-axis to give me r. And I'm going to write these in point form. So this very first point has a theta of 0 pi, and then r of 2, because it was up 2 units. I'll keep going through to find my next point. It has theta of pi over 2, and a radius, or r, of 6. So it's 4 above the center. Keep working through. I'm going to go to my next position with an angle pi, and put that down to 2 for my radius. When I do move to 3 pi over 2, notice that I end up with a negative radius. Now remember how that translated when you graphed yesterday. How is that negative radius going to change things? And I may want to rewrite this so that I have a positive radius. So I will come back to that in just a little bit. Let's finish off our last point, and we'll plot, and we'll revisit this point here that is going to give us maybe a little bit of trouble with the negative radius. We'll revisit that when we start to put it on a graph. So then my last point is the point where the angle is 2 pi, and that is a radius of 2 as well. So we'll put these points again all together on the graph. I'll plot those polar coordinates. So I will go, my first one is 2, 0 pi, so no angle movement. The next one is 6 pi over 2, so 1, 2, 3, 4, 5, 6 at the pi over 2 position. Then I have 2 pi, that puts me out 1, 2 pi. And then here's that pesky one. So what I'd like to do is just think about that point where that graphs. So negative 2, 3 pi over 2 means that I'm going to move to the left 1, 2. That's negative 2 radius. And then from there, I move 3 pi over 2. So that means 1.5 pi more. So that'll put me, here's a half pi, here's 1 full pi, here's 1.5 pi. So that point is going to put me up here. What would be another way to name that point with a positive radius? Well, if I went out 2 and then moved up that same direction, let's change color on there, move out 2 and then up in that same direction, this would be the same as 2 comma pi over 2. So that could be plotted as 2 pi over 2 as well. So when I get that point on the graph, 2 pi over 2, that would be this position up here. And then my last point is 2 pi, and so I'm going to actually end where I started. Okay, so this is where knowing what curve I'm graphing is going to be helpful. We decided that this is an inner loop, and so when I graph this curve, I've got to keep that inner loop in mind. We called that, let's go back to our picture. This was a limison with an inner loop. Okay. So we'll start from the beginning. Here's my first point. I put my pen at the first point, and then I'm going to go up to that top point, back down. I'm going to continue my curve. It's going to hit the loop, come back down, and go back to the beginning. Let's graph that one more time. Replot all those points, and then we'll start with the pen on there again. So I have 2, 0 pi. I have 6, 1, 2, 3, 4, 5, 6 pi over 2. I have 2 pi. And I have 2 pi over 2, or negative 2, 3 pi over 2. Same thing, gets me the same position. And then I come back and start where I ended. So these are curves. When you're graphing, just keep it in mind that these are curves. And keep in mind I need an inner loop to be my final graph. So I'm just going to connect as a curve, connect as a curve, connect. It's going to go through and around and connect as a curve. So there is my limison with an inner loop. All right, let's do some where we have some petals. So we're going to move on, and we're going to start them the same way that we did the other ones, where I need to graph this function first. And notice now I have changed the number in front of the angle, and so that's going to change the way this original graph comes together. Because there's that 2 there, I'm going to, when I start to number my thetas, 2 pi, remember that's 2 pi divided by 2 to get pi in that position. So I will finish off the rest of that graph with the breakdown, where I have the quarter mark, the halfway mark, the 3/4 mark, and the full mark on that graph. And this graph is going to top out at -6. And so before I get any further and graph any further, one of our directions was we had to decide which curve we're graphing. And so let's look at what this graph itself, what the layout looks like. It's got a number in front that changes the amplitude, and then it's got a number in front of the angle. So if I go back to my classic polar curve page, it looks most like that rose situation. And so I know that the angle in front is going to change the number of flowers that I get, or petals that I get. And that will be decided by the way the graph looks. So let's, oops, I went a little too far. Let's back that up. Let's sketch our cosine graph. So cosine starts at the upward position, then I go down to 0, negative, back up, back up. Okay, so there's my cosine. So when I start to set up my points, I've got at the 0 pi position at the start. Start up at 6, then at 4, and I'm at 0. I'll keep going through that graph. The next point here is at the pi over 2 position is negative 6. I'm going to have to think about that, but just remember, it's just to move left 6 and then a pi over 2 movement from there. So when we plot that, we have to keep in mind that my radius is negative. Go back up to the 3 pi over 4 position. It's at 0, and then I'll finish this one off at pi. And pi is up to 6. Now, as we start to put this graph together and plot these points, you're going to notice something that's going to happen a little bit that we're going to have to discuss. But let's get started. So 6, 0 pi is my first point. These are curves. I have 0 pi over 4. So at 0, my angle, it sort of doesn't show up at all. It just is going to be that point at the origin because I don't have a movement of anything. So it doesn't even really matter that it's at pi over 4. Then my next one is this funky one here, negative 6 pi over 2. So I move to the left 1, 2, 3, 4, 5, 6, and then forward pi over 2. And then I'll move on to 0, 3 pi over 4. Well, that one's back in the center. Okay, things are looking a little bit weird here. Then my last one is at 6 pi. And so 6 pi would be 1, 2, 3, 4, 5, 6 out, and then I move all the way over to pi and put my point over there on the other side. Okay, so I'm going to start to graph this curve. Keep in mind that it's curved. This was my first place that I started. Then I went to 0 pi over 4. That puts me in the center. And I go down. It's going to bring me back up. And then I stop here. Now, what's wrong with this picture? It's not complete. It's not finished because I didn't go get all of the points that I need because the period was adjusted on this one. So what I'm going to have to do is go back to this path and extend this out further. So I'm going to get more angles that I'm going to use to keep me going around this this graph. Again, I started here, I curved around, I got through all these points. I'm just graphing these as curves, and I stop right here at that 6 pi. So let's continue this graph. Well, cosine is not easy to continue. It's going to go down to 0. It just repeats itself over and over again, back up. Continue this down. The only thing that I'm going to need to add is the angles that I'm going to use. So if I continue to count in this interval pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, which is 3 pi over 2, 7 pi over 4, and then I'll finish it off at 8 pi over 4 over 2 pi. So I'll stop there and see if this is enough to finish off my graph. And maybe it is, and maybe it isn't. But and I have to add more if I still need more points on it. So I left off at this pi position here. I'll move to the next one. That one is 0, 5 pi. Keep going down on the graph. 3 pi is the next one. Okay. 3 pi over 2. I am at negative 6. The next one. At 7 pi over 4. And then finish this off at this next point up here at 2 pi and 6. So let's finish plotting those points. I left off here at this point 6 pi, so 0, 5 pi over 4, well, that's back in the center again. And so if I continue to connect there, I'm going to go back to the center. And my next one is negative 6. Remember, a negative radius, so that means I move to the left 6. My next point is negative 6, 3 pi over 2. Remember, that means I move in the to the left to negative 6. But then I have to move the angle 3 pi over 2. So from there, I'm going to head in that direction all the way around to 3 pi over 2. That gives me my next point. So to continue my curve, I'm going to curve up to there. I get to my next 0, 7 pi over 4. That puts me back at the origin. Continue down. my last point, 6, 2 pi, puts me back at the position where I started, so continue my curve, and you can see the 4-petaled rose that we made. So let's just follow it along in order from start to finish again. I will do it in a different color. I'm starting right here with my first point at 6. My curve brings me to the center, down, around. I continue in that curved flow, hitting all of the points and finishing off my flower in the end. Again, keep in mind that these are curves that you're graphing, and we're just doing a sketch, so it doesn't need to be perfect, just the general idea of what the curve would look like. So let's finish it off with our last. We have another rose. If you look back again at the common polar equation, common graphs that we had at the beginning, the classic polar curves, again, that's in a standard position for a rose. And so we're going to start the same way that we did on the others, by sketching this graph as y equals 3 sine 3 theta. Because there's a 3 in front of the theta, that's going to change how we number our graph. I'm going to give myself plenty of room so that I can expand this. 2, 3, 4, start that same way. Keep in mind that's 2 pi divided by 3 there, 2 pi over 3. Do the halfway mark, pi over 3, pi over 6, 1 pi over 6, 2 pi over 6, 3 pi over 6 gives me pi over 2 in that third spot. 2 pi over 3 is where I would stop. Amplitude gives me up 3 and down 3. I'm graphing a sine curve. Sine curve starts at 0, back to the middle of the graph location, down to the lowest point, and then it goes back to the start. So here's the sine curve that I'm going to start with. But as in the last problem, when I adjusted the period of the graph, it didn't quite complete the graph. And so we needed to get to 2 pi in order to 2 pi here in order to finish the graph. I'm going to do the same thing with this one. I'm just going to extend this out to 2 pi. And maybe that's too far, but I'm just going to continue counting the tick marks the same way. 1 pi over 6, 2 pi over 6, 3 pi over 6. This is 4 pi over 6, 5 pi over 6. 6 pi over 6 is a pi. 7 pi over 6, 8 pi over 6, I can reduce that, that's 4 pi over 3, 9 pi over 6, that's 3 pi over 2, 10 pi over 6, that's 5 pi over 3, 11 pi over 6, and then 12 pi over 6 over 2 pi. So that's getting me all the way around. And I will just continue my sine. I just am going to keep graphing that same sine graph repeatedly until I get to the end. All right. Again, keep in mind that on this graph, I'm going to use the x-axis to find my theta and the y-axis to find my r, and then I can write the points down that I'm going to graph. So my first point is 0, 0 pi. Follow along the curve. My second point is 3 pi over 6. Keep working my way through. 0 pi over 3. There's that third point. Moving on. And at negative 3 pi over 2. Here at 0, 2 pi over 3. I'm going to go on to the second portion that I graph, the second period of that graph. So I will be at 3 5 pi over 6, 0 pi, negative 3 7 pi over 6. 0, 4 pi over 3. And now I'm going to finish the last piece, the last period of that curve. So that puts me up at 3 pi over 2. 0, 5 pi over 3. Negative 3, 11 pi over 6. And lastly, 0, 5. All right, so we've got a lot of points on this one. I'm going to start graphing them, and I'm just going to continue to graph until I get back to the beginning position. Notice that these negative radii that we have in here in a few spots, that we're going to have to account for that being negative when we think about our angle, so we'll work through that. But I will start with my first position here at 0, 0. That puts me in the center. 3 pi over 6, I move 3 up pi over 6. There's my next piece. Now keep in mind, this is a curve. It's going to get to that point. You can sort of see things coming together. And I go to my next one, 0 pi over 3. Well, that puts me back in the origin. I'll continue that curve back to the origin. Negative 3 pi over 2. That means I move to the left 3 and then forward pi over 2. That'll put me down at actually 3 pi over 2 in position, but if I start at negative 3 and move pi over 2 in that direction, that'll put me down in that place. So here's my curve, and I hit that point. Get rid of my arrow here that I used to graph that. There I am. I'm going to continue to move. Now I'm at 0, 2 pi over 3. That puts me back in the origin. I'm over here, 3, 5 pi over 6. So 3, 5 pi over 6. Continue my curve. 0 pi. Puts me back. Oh, okay. Well, here I am. I really only needed those points to stop. I went all the way to 2 pi, but what's going to happen if I continue to plot those? That negative 3, 7 pi over 6, that will be left 3, and then I end up being right back where I started again. So it's not necessary to go through those last ones on there. I only need to graph until I get back to where I started. So I have a 3-petaled rose for our final polar equation graph.